you, probably.
Okay.
But you're not changing the one you're sharing, I think.
Oh, okay.
Not trying to say I'm an expert, but at least, wait, we have so many things open.
Is this going off my time?
Yes.
God.
No, that is the plan. No, you're okay.
This is presentation mode. Yeah,
That's the right one, right?
I feel like a senior, very much. So why improving resilience and efficiency? It has been said before, I can be brief. We want resilient and efficient animals because we think they are better at dealing with the increasing frequency of environmental disturbances due to climate change. Yep, and we want to improve resilience and efficiency through breeding, which is one of the goals of GenTore. But when we started with GenTore, we had some questions. How can we breed for more resilient and efficient animals if these are very complex traits, depending on many factors? Well, how can we breed for resilience and efficiency if we don't have practical and scalable definitions? How can we breed for these if we don't have any models that can predict these traits already early in life? And how can we take into account the variation that can happen, for example, in efficiency throughout life? So these were some of the questions that we'd like to, well, at least shed a light on within GenTore. And we chose to apply or use data to solve some of these questions. We know that many data are being collected. These data can be on farm specifics or farm characteristics like herd size, but we also have farm and animal performances data from the monthly milk recording system. But we also have increasingly often precision livestock farming technologies on farms, aka sensors that measures milk yield, activity, rumination. And a characteristic of these PLF technologies is that they are cow individual, they're longitudinal, and they're high frequent. And it is this characteristic that we want to explore and exploit to solve some of the answers that I just mentioned. So at the start, we did not have a practical and scalable definition, particularly not for resilience. So we worked out several approaches to do so within GenTore. One of the approaches that we used was developed by Marieke Popper and her colleagues. And she used the responses in milk yield to environmental disturbances, and she used the assumption that resilience is the ability of an animal to be minimally affected by disturbances, and if they are affected, that they recover quickly. Now, she used milk yields that are provided by automatic milking systems, and she used these measurements, and she also used a predicted milk yield, and the difference between these two, that's what she used to develop resilience proxies. And she came up with two, the variance and the autocorrelation. And in the upper graph, you see an example of a cow that has low variance and a low autocorrelation. And we assume that this animal is a resilient one. On the bottom graph, you see a cow that has high variance and high autocorrelation values. And we think that this is a less resilient animal. Now, Marieke also calculated the heritabilities of these proxies. And they were both heritable, with variance having slightly higher heritabilities than the autocorrelation. And she linked it also to traits that we think or that we link to resilience, like fertility, production, or diseases. Both of these traits, these proxies, also had genetic correlations with these traits, although the variance showed higher genetic correlations than the autocorrelation. So this work, we thought, okay, the variance seems to be a very good proxy for resilience. Now, as I mentioned, Marika used daily milk yields from an automatic milking system, but not everybody has an automatic milking system. So we also explored a different way of defining resilience, or a different proxy for resilience. And we came up with the lifetime resilience score, which is a cumulative result of the ability of a cow to recalve and pass on her genes to the next generation, taking into account aspects of production, fertility, and health. We wanted to use readily available data on many, many farms. And it's a score where we also compare an individual cow to her herd mates and peers. So that makes this lifetime resilience score also adapted or adopted to local circumstances. It's a very simple score. It has just a few areas, and it applies bonus or malus points depending on an individual cow performing better or worse than her peers. Finally, a trait that has been used is the longevity, where the assumption is that longevity is the result of all the positive benefits of resilience. And we have the true and functional longevity, where the true longevity is the ability of an animal to delay any culling or death. And the functional longevity is the ability of animals to avoid involuntary culling. So we had several methods, ways to define resilience. Then we also wanted to predict resilience using PLF or other data, but at least predicting early in life. And one of the things that we did is, well, I just talked about the longevity, the functional and true longevity. And we investigated or studied which traits measured in the first lactation were associated to culling and therefore associated with longevity. So a survival analysis was conducted with French Holstein cows to compute the longevity, and that was associated with traits measured in the first lactation. And we saw that insemination status, calving ease, conformation traits, in particular the udder depth, clinical mastitis, somatic cell count, and displaced abomasum, were traits that had a major effect on culling and therefore a major effect on the two longevity traits. And these risk factors for culling can be seen as early predictors for the length of true and functional longevity. It's a way of predicting. Another way of predicting was to use precision livestock farming data, and where we try to predict the ranking of resilience using these high-frequent data. So we took resilience, in this case, the lifetime resilience score as dependent variable, and the PLF data collected through the first lactation as independent source. But then the challenge is, if we have this longitudinal data, how to summarize it into variables that say something, that can be used as predictive variables. And we took basically two approaches. The first one is a summarizing approach. So we took the data collected over one lactation and we summarized these into curve parameters, summary statistics. This has the benefit that it's a very generic approach that we can apply to many more PLF technologies. And it also has the benefit that it perhaps does not require a lot of data quality and quantity. The downside is we're going to summarize quite a long period, and by summarizing it, we might ignore some of the disturbances. So the other approach was focusing really on those events where we see a deviation in a predicting milk yield. And we try to characterize these specific dynamics and use these variables as potentially predictive ones for a model. The benefit of that is then we really look into how cows react on environmental disturbances. The downside is that it put a lot more of requirements on data quality and quantity than the first method. We used, by the way, a logistic regression model and a machine learning model to predict resilience, the lifetime resilience score, using data in the first lactation. A quick glance here, you will see that it doesn't, well, we can predict it. It doesn't really matter which method we are using. But I would like to highlight that if we're going to use the curve dynamics, so the specific details when its milk yield is deviating from the predicted one, it seems to be better performing than the curve parameters, but there's a huge range between farms. So we were unable to develop a one-size-fits-all model. And the second thing I want to briefly highlight is that when we use the machine learning approach, the data-driven approach, in this case a random forest, and we provided this random forest the same curve parameters as we provided the logistic regression model, it doesn't perform a lot better, which is, jammer, sad, but hey, at least it's not worse. But it was a little bit surprising that when we give that random forest just simple daily values, it also performs similarly. And to me that meant, oh wow, so we can just simply do daily values of sensor measurement and can have a predictive model rather than extensively do extensive data pre-processing, which is needed for the logistic regression. And finally, models and methodologies to account for the variation throughout production stages or lifetime. And here we specifically looked at the efficiency. And when we talk about efficiency within GenTore, we basically talk about feed efficiency. And that's measured through the residual feed intake, which is simply put the difference between actual and predicted feed intake. Now, a common method to get to this residual feed intake is the use of linear regression. But by design, that method is incapable of taking the known variation into account because it assumes that the coefficients are constant through time, which they are not. We know that. So GenTore tried a new methodology and came up with the dynamic residual feed intake. So we can measure residual feed intake at any time through a multiple trait regression. And I don't know the ins and outs, but people in this room do know. But it's the difference between the animal effect of the actual dry matter intake and the animal effect of the predicted intake for different energy sources, like milk, weight, and body condition score. How am I doing in time? I think it's, no, that's good. With what I showed you, the GenTore has some applications and impact. We know that we can use longitudinal PLF data to quantify and predict cow-specific resilience. So a farmer can rank animals on his or her farm at any moment in time. And when we can predict it, also early in life, this can be a tool for farmers to decide which cows to keep and breed and which cows to replace. And it established the best animal in environment herd. We also identified risk factors for culling, and identifying these risk factors can help farmers and their advisors to focus on the areas that they do not score very well and try to improve that, and by doing so, improve resilience as well. And then finally, we have methodologies that can take into account the variation. It also means that if you rank animals for efficiency using the residual feed intake, it will vary across time. It will not be constant. And I did not say that in a previous slide, but GenTore also looked at the best time period to quantify the feed efficiency, and that happened to be the steady state period, so for dairy cattle, the mid-lactation. It has been already briefly commented by the previous presenter that with all the work that we try to do with efficiency and feed efficiency, we do rely on actual feed intake, which is still a costly business to do so. and that will continue to be a limiting factor so far. And that was it. Thank you.
Thank you, Claudia. We have time for
Welcome.
a few questions.
If you're going to apply this for genomics, for selection, not for picking the best cow in the herd, but most selection these days is done on genomics, and you're using as your sort of gold standard the lifetime efficiency of the animal. So why don't you just develop a good genomic prediction equation for lifetime profitability or lifetime efficiency?
I feel a new project coming up here. This could be an approach, I guess. Yeah.
If I can just add to that,
Sure.
the correlations that Marika found between her resilience disturbances and longevity were not one, were a long way off one. So that suggests that in addition to using some kind of lifetime measure, there may be additional benefit from using these shorter term variabilities, which we get earlier in the life cycle as well.
Thanks, Nick. Thank you, Claudia. Just sort of following that up to some degree, I mean, how important do you think this is in terms of looking at the opportunities for predictions and tools at an individual farm level, where we're looking at that local basic production environment? Because obviously we've got genomics being massively important at population level and in the long term, but for a farm that could go out of business with a high feed price, how could we use these tools that are out there for that farm level opportunity?
Well, I think we tried to do something similar within a GenTore, and we developed a demonstration software tool, where we used the lifetime resilience score basically as first concept to help farmers and their advisors to focus on certain areas for their management. So yeah, good question. Do you want to add something?
Tomorrow.
Good job.
Time for another question, if anybody has one. Music.
So one of the
Sorry, Music, you need the microphone for the live stream, so we can hear your voice broadcast across the nation.
all right, thank you very much. So a very quick question on these indicators that you are getting on the farm. So one of the concentration there is on milk yield from robotic milking.
Yeah.
But we know that the robot also gives us quite a lot of other parameters.
Yeah.
Temperature and all those kind of things. Have you also attempted to use the other indicators as well?
No, but I agree with you fully that we underutilized the information that can be provided by an automatic milking system. I completely agree with you. Yeah.
Perhaps in addition to this question, thank you. Perhaps in addition to that question, have you also considered asking the farmer which of his cows would be the most resilient or durable cows? Because I think in New Zealand, that is one of the, or by far the best indicator to predict the durability of their cows. When the farmer just says from his heifers, this one will be the best, this one will be the most durable. Perhaps it works the same with resilience. Would that be?
Well, I know that Jonathan has also been involved in a number of stakeholder meetings and asked that question. So maybe Jonathan, you can reply on that one.
Thank you, Claudia. I think what's been surprising is when we looked at some of these data sets in terms of 5-year data sets, and we actually looked at stakeholders and we saw which cows did survive. it wasn't always the ones they predicted. And actually, it was a lower predictive value. So actually, the sensor data and those outcomes did beat the kind of farmer perception more than in those stakeholder meetings. We surprised quite a lot of the farmers. Just picking Mazek's point up slightly as well, we did do some work looking at accelerometer data as well from those, and it did improve the prediction in some of the work too.
Thank you, Jonathan.
Thank you. Are there any questions in the chat? Nope. Is there anybody actually watching this outside? Hi, everybody. Thank you very much, Claudia.
Thank you.
Let's make sure we close this down completely so we don't have the same thing as last time. You still know what you called it.
This one.
Yes, that you.
Okay, so I have the pleasure of presenting the final topic in what we've called these GenTore results, which can contribute to future-proofing European cattle production. And I'm going to talk about which cow in which environment and the tools that we've been working on to help address this issue. And because I'm also chairman, I can overrun without anybody standing up and threatening me. I did want to thank the people who helped me put this together, so Albin, Florian, Birgit, and Lotta, who worked hard to put this all together, and of course the whole GenTore consortium who've contributed to this in lots of different ways. And what you should know is you're getting the live version of these 4 themes. There's also a document, a 2-page document for each of the themes, which will be on the website. And behind that, there's a longer document where you get a link to all the different results that have been produced that contribute to that theme. So the idea is, once you've gone away from here, you can go on the website, you can pick this all up again, and you can tell all your friends what a fantastic read it is as well. Okay, so the context for which cow in which environment. So you're going to get a lot of repetition, but that's good, they tell us, when you're teaching. Europe has an incredible mosaic of topography, weather conditions, farm types. And in addition to that, there's an increasing environmental variability which is coming, which may already be here, with climate change. So it's fairly evident there is no one-size-fits-all optimal balance between cattle resilience and cattle efficiency. We can imagine environments which are quite demanding, where animals need a good resilience, and other environments where they're much more protected and they need far less resilience. And likewise, some of those environments allow them to express a high efficiency and others won't. So what is the right balance? That's the question we're talking about here. So from a farmer perspective, which cattle is best for the current and likely future environments? So if you're a breeder, you just add geno. What genotype is best for current and likely future environments? And that includes also having sufficient resilience in your animals to cope with possible current and future disturbances. So if we want to answer that question, we have to consider a number of things. We have to actually understand and be able to characterize what is my current and future local environment. What kind of cattle do I have in terms of efficiency and resilience, because this is GenTore? How will my cow perform in a given environment? So when I bring those two things together, the environment and the cattle. And then finally, what are my key levers to better match my animal to the environment? Now, of course, these are things you've heard about already in the different talks today, but we're wrapping up. So if we take that first question, what is my current and future environment? So GenTore created a new farm production environment data set. This was done by combining European FADN data and meteorological data. So there are now 2 cattle data sets, one for dairy, one for beef, which contain a wide range of variables at regional level. So these provide the opportunity to analyze and estimate for particular regions or particular farm types, farm efficiency and farm resilience. and therefore to be able to start to identify what might be needed to adapt to future changes. These data sets are publicly available, so you can go on the website, you can find them, they can be used to ask questions about which environment you have. Just to give you a couple of examples of what can be done with those data sets. So this is a retrospective economic analysis. The graph is showing the gross margin change. So these are the losses in gross margin relative to the baseline of 2007 up through to 2013. What's evident on this graph is that in 2009 there was a drought, and that affected all of those lines. Each line represents a different farm type region. So you have North Atlantic, you have Southern Europe, you have uplands, you have boreal, and so on. What's interesting to us is that the extent to which these different regions responded is different, and how they recovered is different. So that's telling us that different regions and farm types can react differently to climatic disturbances. The second example was a forward prediction. This is a prediction of what might be the likely climate change effects as we go forwards. So in the panel with the graph, the top one is the current situation. Going from light yellow to darker brown, it's the milk productivity levels in the different parts of Europe. The bottom two graphs are showing how things will change for 2030 and 2050. And basically, the more red it is, the worse it's going to be. These are based on available forage yields and the predicted impact of climate change on those forage yields. And what it's saying is, if you're in a yellow or a red region, you have a higher risk of suffering from forage shortage, and thus a higher need to adapt your systems and perhaps also your breeds to anticipate that change. So this is helping us to understand where are we heading with our local environments. The next question was, what kind of cattle do I have? So this has just been covered for the phenotyping very nicely by Claudia, so I won't talk about that other than to say we have tools which are helping us to phenotype resilience and efficiency. And exactly the same for the genomic tools, which Mons covered in the first talk. We have tools for improving genomic evaluation for crossbreeds and admixed, for G/E. So GenTore is helping us and helping the breeding industry to have the tools to enable better selection in crossbreeding systems and within and across environments. Moving on to the third question, what happens when we bring those environments and cows together? So that's the G/E question. And again, this is something Mons presented, so I'll go quite quickly, that traditional genomic G/E, oops, we've lost the microphone, I believe. No, it's back. Anyway, I'll go closer. Okay, that's too close. So the traditional G/E genomic models assume similar effects of G/E across the genome, and of course that's something that we wanted to look into. So GenTore has developed a pipeline. It's difficult to be here and read. So the question is that microphone off, or am I going to deafen you all? We'll do that. Okay. So I won't present this again because Mons presented how this protocol works. I'll skip straight through and say that what we have is a modeling protocol that can be applied to multi-trait and to reaction norm models. It delivers genomic breeding values accounting for different G/E effects. The nice thing is it's based on readily available software, so it should be easy uptake by genetic evaluation centers. We've also looked at G/E in another context. So we have looked at systemic biology models to quantify G/E. So that's coming in from the other end. That's saying, how do animals function? Can we describe that in a way and model that, how that reacts together with the environment? So this is part of the work which Alben presented right at the beginning. These models, explain how animals function by saying they have abilities to acquire resources, so how much their intake capacity, and then they have abilities to partition those resources between different life functions, which can be production, which of course impacts efficiency, and they can also be other life functions which impact the animal's resilience. And in these models, we include the biological mechanisms of how that work, but we also include genetic drivers. And we've already been able to show, and again, another graph you've seen before, that when you look at the allocation and acquisition parameters of the best cows, the profiles of the best cows in different environments, what you see is that they're not the same profiles for different environments. So that's suggesting that the best adapted animals are slightly different in different environments. So the last question which I asked was, which are the key levers which allow us to better match my animals to my environments? So the first thing we've done, and again, Alban presented this at the beginning, is to couple up this mechanistic model with a breeding scheme simulator. And that allows us to ask the questions, if we take a known set of animals with these acquisition allocation parameters today, we run them through, let's say, 20 years of selection, we can then look at what the allocation acquisition balance is in the future and look at what kind of gains we're getting and where we getting a good preservation of resilience, for example. And this is the results that Alban showed. And what we see here is that with this new prediction method, we can predict the performance of future cows, which are accounting for the potential energetic trade-offs. And then we can see what is the impact of selection on the resilience indicators, in this case mainly body reserve dynamics and lifetime efficiency. And then we can see the outcome of selection if the environment changes dramatically. So just a brief word about lifetime efficiency. For us, short-term feed efficiency is a kind of pure measure of efficiency. Lifetime efficiency, because the animal has to live longer, incorporates resilience. So a good lifetime efficiency is a good balance between resilience and feed efficiency. So that gives us a better insight into the underlying mechanisms, and we believe that's of interest to breeders for benchmarking different breeding strategies. And we've taken that a step further. GenTore has studied the whole production system using life cycle analysis. It has used social life cycle analysis, so that's asking questions of how a system impacts the farmers, the workers, the community, society. And on the other hand, we've done environmental life cycle analysis. So that obviously relates to all the kind of environmental issues that Eileen was talking about. And the interesting thing is to combine those two. So that's what's being shown in this scheme here. If you combine the two, you can start to see where not only what we're doing in terms of bioeconomical modeling, but also in terms of the societal consequences versus environmental consequences come into play. And the idea is that such a tool opens up for a discussion with stakeholders on what it is we actually want to achieve, and therefore can be used to provide a better informed choice in building broad breeding goals. Now that all may seem like a pipe dream, like we've gone several steps too far and we've lost the plot. And these are indeed tools which are there for discussion. But the tools that we've developed in GenTore have also included taking some of this information into on-farm ranking tools. So what you have on the screen here is a shot from a livestock market in Ireland, and what you could see down at the bottom if I had a pointer is that there is a value for the replacement index, and that is coming from a model developed within GenTore. So in Ireland, they have been working for a while, and they've developed this cow's own worth index, which takes the genetics of the animal, incorporates any crossbreeding effects, adds in some of the individual performance of the animals where it's available, calving dates, because in Ireland we're in seasonal calving system, and the age of the animal, and that allows to give each individual cow a cow's own worth ranking, which can then be used for making decisions about culling or not culling, And it can be used for making decisions when breeding. Are we breeding replacement animals? Are we crossing off onto beef, and so on? Within GenTore, the same thing has been done and extended and developed for female beef cows, with a beef zone worth index and a beef future profit potential index. And these have actually now been deployed in Ireland and are being deployed in France. And this was just to show you on the graph down here that if you look at the values predicted by the system in terms of economic worth along the x-axis, they match pretty well with the prices paid at market up on the y-axis. So these things are actually now getting out there. So GenTore has come a long way. We started off with a black and white drawing. We now have coloured things in. That's how we work in research. The conclusion, I would say, is that we have developed tools to evaluate the current and future match between genetic and environmental resources. We have tools which allow us to ask, is my current match good? What are the options for improving? And what can be the longer term consequences? Now, of course, it's only one 5-year project. We haven't solved everything in the world. Some of these tools are publicly available. Some of them are usable directly by breeders, for example, and advisors. Others are still research tools which remain to be developed. So I think there is going to be an after GenTore where a lot of these things get worked through and taken further out into application. And with that, I will thank you for your attention. And I'll give the microphone to Norley if there are any questions.
Yes. Yeah, I mean. And let's try meanwhile if it still works again, or there you are.
So Nick, we coloured only inside the lines in your analogy there. What would you have done as our fearless leader to colour outside the lines? What did we not do?
You mean to characterize environments
Yeah.
better?
Shall I just go back with the microphone?
I think what would have been really good would have been able to go a bit further. We have environmental descriptions which are very good at farm level, but don't necessarily match with our animal descriptions. And it would have been to try and get closer to environmental descriptions which can be directly mapped onto animals. It was an idea we talked about at the beginning and then didn't necessarily have the resources to achieve, but that would have been really helped us with G/E, for example, and the kind of things you've looked at with breeding values affected by weather, for example.
More questions? Can you try the microphone again? Oh, sorry. There you go.
If G/E were important, we would expect different farmers to have different breeds of cattle. And in fact, they do. So did you consider what's the G/E that causes some farmers to have Holsteins and others to have Swedish Reds or something?
It's a very, very interesting question.
It's not working, right?
And it's always fascinated me as a nutritionist. If you look from a nutritional perspective, there should be massive G/E everywhere. You know, you feed your animals badly, you get very different performances, and some animals do better than others. And yet, in most genetic evaluations, G/E tends to come out rather limited. I don't know. Is that because we're within a safe bubble up until now? May have differences in the ways we feed animals and the environments, but it's nowhere near as big enough yet to see real effects. And if we go to situations where there are massive differences, then it'll become much more important.
But you'll never be able to create by selection as big a differences as we already have between breeds. So the best data must be the between breed data.
Yeah, possibly. And then that takes us to crossbreeding. And then I throw the microphone over there to Morten. But certainly I think we could be moving away from the kind of, at least in dairy, where you have one breed and only one breed and you wouldn't never have anything else, and start thinking a lot more about what you can do by making better use of the breeds. Thank you. We have room for one more question, if anybody has one. Nope. Okay, so we have a small session here with 2 presentations from 2 projects who will be continuing in this area, just to let you know that the work goes on. And then we have our stakeholder panel and discussion with our guest presenter, who actually knows what a cow looks like. Yes.
Thank you, Nick. Est-ce que ça marche? Non.
No. I think we're good.
Thank you. So I'm going to present a new, a rather new H2020 project called Rumigen, which again deal with cattle, and the complete name is Towards Improvement of Ruminant Breeding through Genomic and Epigenomic Approaches. So the objective of Rumigen is to improve breeding scheme in terms of efficiency, resilience, diversity, genetic diversity, maintenance of genetic diversity, I would say, and adaptation to new environments in different bovine breeds through genetics, epigenetics, new breeding techniques, and including genome editing. And with a very important social science level to evaluate the societal acceptability of new breeding technologies and breeding strategies in general. So a lot of co-construction with the stakeholders and the citizenship. So the overall project structures is the following. There are 9 work packages. Work package 2 is the social science work package, and it is supposed to interact with all the technical work packages with a very strong links in order to be sure that what is developed, in fact, is compatible with some room of acceptance, and I will develop that later. Then work package 3 and 4 are genetics. Work package 5 deals with genome editing, and work package 6 and 7 with epigenetics. Work package 8 is an integration work package, which uses as input data all the results from the technical work package 3 to 7 to elaborate a technical solution to be with the objective to provide tools and solutions and proposal for dissemination, and within the room of acceptance defined by work package 2. And work package 9 is in charge of the dissemination to the stakeholders, but also the society and the end users. So the project involves 18 partners from 9 countries throughout Europe, and it is coordinated by Eric Payou from INRAE. A quick look at the different work packages. So in work package 2, the goal is to ensure that the outcomes of Rumigen in terms of new approach to breeding are acceptable, as seen from the viewpoint of stakeholders and citizens. So in the first step, we define a sort of room of acceptance, which is a reasonable expectation of what the public can accept in terms of approaches. within this room, provisional room of acceptance, we define scenario. We test this scenario in relationship with the stakeholders and the citizenship to obtain a sort of confirmed room of acceptance. And this defines the rules to be applied in Work Package 8 in terms of technical deliveries. And so a lot of dialogue with the stakeholders and the citizens. Work Package 3 deals with the trade-off between trades in the context of climate change, and it will study the impact of heat stress with the consequence of on production or production health, and especially the how do evolve the trade-offs between production and the other traits, especially in terms of genetic variability and genetic correlation. And we also study the effect on the progeny, especially the impact of heat waves during the gestation on the performance of the next generation. And all these studies rely on large-scale already existing data in France, Spain, the Netherlands, combined with meteorological data, and also in with a GBI study between Denmark and India on Jersey breed. Work Package 4 is typically a quantitative genetic work package. The aim is to measure the effect of genomic selection on diversity and inbreeding, to locate on the genome the regions responsible for inbreeding depression and genetic load, to develop method of genetic improvement without jeopardizing diversity and functionality, and also to study the importance of pangenome on genetic diversity. The pangenome being especially the part of the genome. It includes the part of the genome which is not present on the reference assembly, and which can explain a part of the diversity which is not yet studied until now. Work Package 5 deals with genome editing. It will be based on 3 different approaches. First of all, a position paper to present the goals of that genome editing could achieve and the associated risk. Then the technical work will be focused on the consequence of reproductive technologies, including genome editing, on genome integrity, especially mutation rate and so on. The off-target in genome editing, for instance, and a few practical applications, a comparison of genome editing versus introgression, and also the test of some genome editing for heat tolerance gene in sheep based on cattle data with the SLIC gene. Work Package 6 is very heavy, I would say. It deals with epigenetic biomarkers to improve selection and precision farming, with the idea that epigenetics can be useful to predict breeding value and phenotypes, and can be integrated in prediction. So we'll study the plasticity and the dynamics of the sperm epigenome, and the impact of the sperm epigenome on embryo development, on bull fertility, and on progeny performances. And we will also study the impact of cow epigenome on their own performances. The work package will include the development of a technical tool, which is a sort of epichip, so a tool to measure methylation marks on a very large scale and at a reasonable cost, exactly as a SNP chip. And in order to be able to use this tool on a large scale and to see how important it is for prediction. Okay, so Work Package 7 also deals with epigenetics, but on the environmental impact of the impact of environment on epigenetics, especially the metabolic demand, the heat, and the immune and infectious disease, to define the drivers of epigenetic markers which orient the genome expression. Work Package 8 will integrate everything. First, what do you want to improve and how, and in which room of acceptance, and it will provide, hopefully, a solution to, or at least ways to go to adapt to heat tolerance, to select without losing too much genetic diversity, and potentially how to use genome editing in breeding scheme, and how to use methylation marks in prediction. The idea is to provide guidelines and tools which are directly available by the breeders. And the dissemination will include nearly all kinds of information, the data, the knowledge, the proposal of breeding strategies, the software, and application tools, with targets which are both the stakeholders, the breeders, the farmers, and also the citizens. I thank you for your attention.
Thank you, DJ. So now, Virginia.
Okay, good afternoon, everybody, and thank you for the invitation for showing our project. So the project is Bovine, is a beef innovation network in Europe, and I will talk a bit about the project overview. I'm Virginia Resconi, and I'm a thematic leader, and I'm working in the University of Zaragoza in Spain. So the origins of bovine, we know that the beef sector is facing many challenges. Here we can see an example of a product saying that it's no evil food because it's a beef made with plant-based. So we hear that beef is accused of many problems. And I think that we have to do something. The sector has to do something. So one thing is to say, okay, we are not that evil, but we need to prove that, and we need to communicate that. But also, I think that we need things to improve. So we can improve the way we are working, and we can try to be more sustainable. But the question is how. So one way to change is with innovation. So the project, the GenTore project, is a good example of innovation, gathering new knowledge or combination of knowledge, and it's very important that we continue in this way. But also, if we look at the beef sector, actually there are a lot of innovation that already exist, but they are not adopted. So. Also, we have work to do in this level. Why? Maybe because low margins, maybe because farms are small or they are not much integrated. Maybe also the research maybe is not really dealing with the problems that farmers have. So we have a lot of work to do in this sense. And that's why we came with this idea to develop a network, a beef network. And the idea is to create a rainbow of actors, a rainbow of knowledge, and all together trying to solve at least in the way we can to improve the sustainability. So we have an influential network in place with this project. So the project is coordinated by Chagas from Ireland, and we are 19 partners from 9 European countries, and also we have support from committed media and advisory group. The project is a 3-year project, and we are in the last period. It will end in December of this year. And although we say it's a network, actually we are many networks. So we have national networks per country, but then we have also trans-European network that are dealing with specific topics. So the process is to identify farmers' needs and then try to search for solutions that address those needs. And we do that separated by the 4 thematic areas I have mentioned, that are socioeconomic resilience, animal health and welfare, production efficiency and meat quality, and environmental sustainability. And we do this process during the 3 times. Each of the year of the project, we did the same process. We have already identified the priority topics. I'm not going to read all of them. There are 24 in total and are in the website. So we have already done that work. And also we did and we are working on trying to find solutions. So the solutions are searched by research innovations, with the European thematic groups that I said for the 4 thematic areas. So we look in the literature, we talk with experts, so many experts working in GenTore, we have talked with them, and so that's the way we identify research innovations. And then also good practices. So this is done with the national networks, and the idea is to find farmers that are doing something that is interesting to show to other farmers. And to show some numbers, at least we find 10 research innovations per thematic area per year, and 2 good practices per year, per country per year. All this information we collect in a repository of the website that is called Bovine Knowledge Hub, and we try to put images, video to be friendly, understandable by beef farmers. We also conduct on-farm demonstrations, so research innovations we try to carry out in a farm context, and then we call more farmers and we show the results. We also conduct a cost-benefit analysis with every benchmark methodology, and we also prepare virtual webinars or national, transnational meetings, and also other types of communications. So some of key success factors that I can mention is that in our project, we have as partners farmers' representatives. So it's easy to engage further farmers or other stakeholders to gather the results. With the national workshops, we drove awareness and enable a regional voice on the grassroots needs. With the virtual meetings, well, was maybe a problem with the COVID, but also was a way to engage more people. And we have internal sharing repository not to have so many emails and file exchanges that facilitate the work. And what we are doing, we try to record everything what we do, so then it can be consulted in the future for anyone interested. So that's all what I wanted to say, just to show the project, and thank you for your attention.
Thank you very much. So those were 2 examples of associated projects at quite different ends of the spectrum. That's really nice to see. And there are plenty of others out there. I'm now going to hand over to Mike.
Well, I'll stay here for maybe with logistics. Good afternoon, everybody. For those who don't know who I am, including myself, I'm Mike Steele. It's been my privilege to be part of the dissemination team of GenTore for the past 5 years. And I'm chairing this session because none of the other members of the dissemination team would. Just for the format, we're privileged to have with us a Dutch farmer who's going to give us a short presentation to set us off. This is the last session of the GenTore project, but perhaps we shouldn't say it's the beginning of the end. It's very much the end of the beginning. I think we've heard today that there's a lot of you going out there to present information this week to lots of other people, and that's the best way of getting the information out. But clearly we need to make sure that it eventually gets down to the stakeholders, one of whom is going to give us a 5-minute presentation on his system in this country on dairy production, beef production. And then afterwards, we have a session that will probably last 20 minutes or so. It's almost open house. So if there's anything that you're burning to get off your chest, this is your last opportunity within this project time. Equally, I've been charged with some questions by our glorious leader that if you don't ask or comment, that I will come round and demand information from. And as part of that, I've flagged up to the 3 young presenters we had at the beginning of the session that we might like them to say a few words. We're particularly interested in looking forward now. We've done a lot of work over the past 5 years. We have a lot of information. Is it any good? What are we going to do with it? So have a think, and let's have your comments. This is being recorded live, so it will be captured. Other than that, let me hand over to Herman to thank him for coming along to join in this. And he's also agreed that he'll partake. You've already had a question from him this afternoon in the session afterwards. So over to you.
No problem, thank you. Thank you all, thanks for inviting me, although I don't know who actually came up with the idea to invite me. Perhaps that will come later. This morning I was milking the cows and feeding them together with my father. One of the cows was in heat, coming in heat, so we were discussing, we always do, what bull we would pick to serve her. So Dad said, hey, why don't you wait for the meeting this afternoon and perhaps you have the answer afterwards. But to be honest, after having listened to these presentations, it's still a little bit difficult. I feel a little bit underdressed, so to speak, in this community. But hey, I will tell you how we breed at home and how my father has done that for the past 50 years. He's now 77, but still in good shape, still milking cows. He was a little younger here, but this gives a little impression of the environment where we have him in. Not the most common environment anymore, but we still milk them in a tie barn based or housed on straw. But I'll not go into the environment too much because I only have 5 minutes, and so we'll dive into the breeding part right away. We still milk and breed the original Frisian black and whites, so there's no Holstein blood in them, and there's no Dutch blood in them either. There's only Frisian blood, so from the little province of Friesland up in the Netherlands there. That herd book used to be closed for 100 years, the Frisian herd book. The Dutch herd book was opened, but the Frisian herd book used to be closed from 1880 to the 1980s, I think. Afterwards it was opened up, and most Frisian breeders, or all Frisian breeders, started to use Dutch bulls as well. There were only a few stubborn ones who kept to the Frisians. And my father was already breeding with the Frisians as well, as he was a trainee on one of the most known breeder farms up in Friesland and took home quite a few cows and bulls from him. So we actually have a herd that comes from that farm. So the original Frisian black and whites. And as you see, two of the most important traits also for resilience, I think, are on these cows. This was Kate 108. She won the Jubilee show back in 1970. It was, I think, one of the most important shows in the world in that time, like the World Dairy Expo is today. That was up in Leeuwarden, Friesland in that time. People from all over the world came to watch that show, and this cow got the grand champion at that time. She was held by my father when he was as a trainee on this farm of the breeder Meekma. And as you see, this cow got the excellent score. She also got an excellent score for her udder, which we probably wouldn't give it anymore at this time, but at that time it was a perfect udder. But she also had a cross height of 1.31 meters, which is this height. She was considered a marvelous cow, 100% in balance, the perfect cow at that time, the most efficient cow, and also a resilient cow, because as you see, these cows are dual purpose, have a bit of meat. And I think the dual purpose type cow is easily the most resilient cow that you would need in times of stress, in times of in times of stress, you need a little buffer on the side of the animals. We consider that a base of resilience. So smaller cows and a little meat on them, a little body reserves. I think that's just by far the easiest way to breed resilience into our cows nowadays. We've actually gone quite the wrong way for the past 30 years, as I'm considered, because once we started, at least I can talk for Holland, once we started to breed for production, we did for a long time, and only selected for production, without taking efficiency into account in our breeding indexes, in our ENET indexes for 25 years. There was no efficiency taken in. And if you only select for production, you automatically select for a larger cow. It's simple as that, if you don't take efficiency into account. And we also did, in the ENET calculations, like we did, models are nice, but not always if you don't do it correctly. In that model, we also selected the bull mothers when they were in production for 100 days. So the heifers that came into production became the new bull mothers when they were 100 days in production. And not looking at the heifers anymore, which heifers would produce the most milk at 100 days? The ones that are able to put their backs, to put the meat, to put the body reserves into milk production. The one with the negative energy balance have the highest production at 100 days. So we also automatically selected, for less body condition scores, for less dual purpose cows. I think these are two basics that can easily be restored. That's the good thing of what we are now, and I think what would be good to breed more resilience into cows. That was an old cow. This is a new cow. So they're still like this, and we breed with her. We breed daughters from her with our own bulls, and we breed sons from her with our own bulls. This one was actually at an AI station, but there's little interest in these cows anymore because they don't reach the highest rankings in the genomics. So no AI stations interested for these cows. But the breeding system is simple. Yep. We only use our own bulls. These pedigrees are totally homebred. All the animals you see on this pedigree are born in our barn, not only the female ones. There's not AI in this pedigree. So using 5 bulls every year from your best cows, serve the rest of the herd with them, do that for a few generations, and you breed on a practical way a resilient and efficient cow. And I think these cows are bred without computers, so I think it's even possible to do that without computers. We've gone a little bit from this type of cow to these type of cows. And I think this had been the result of making a wrong model in the past. We've bred bulls that are actually the one left top is one of us, but the other ones were very, very famous bulls in Holland, used very, very heavily, but I think they're actually just misformed bulls. These were one of the most famous bulls in their times. Today we breed with models bulls that should have been culled as a calf, but that is the number one in the world being used very, very heavily. And I think it's just the wrong way of breeding. Because everything is dominated by the AI stations and they rule which kind of bulls they're putting in. And farmers just use them. Here's another one. If we start breeding for resilience, this one cannot even reach the ground, but she's one of the highest daughters in the world on TPI. We're going to very, very heavily use this animal as a bull mother and use bulls from her and pump it into the population. So we can make models as nice as possible, but it won't, as long as we keep doing that, it won't help to make the good predictions. This is what I would actually like to see. Last picture. We have fundament breeders into the breed, still a few of them, breeding with their own bulls, breeding a family line, breeding a resilient and efficient line with their own bulls. Several breeders do that. AI stations should only be there to distribute semen and not interfere with breeding decisions. Only distribute semen to farmers that use the semen and say, okay, I take a few bulls from the first line, then I take a few bulls from the second line. You have no inbreeding, no line breeding. You have even crossbreeding in the user herds. Let the fundament breeders breed their fundaments, they like it, and don't do it this way. This is what we're doing now. Actually, the breeders are using bulls from the AI stations as well. We all have the same genetics, and we're all fishing from a very small pool of genetics. And it's almost impossible for an AI station to pick bulls from out of that pool. You have to fish in that pool, otherwise you will not have the highest TPIs on your bulls. So these red arrows should be gone. And then we can start improving our breeding structure again, I think. I have so much more to say, but I've already been hinted a few times. So I'll let it with this and see what comes up in the discussion. Thank you.
Thanks very much. Are there any points of clarification or challenge? Or should we move on? Yes, please.
I agree with you about selecting for big cattle. That's not a way to improve efficiency. But is it the case that, in fact, people were worse than just selecting for high milk yield? They actually deliberately selected for high angularity and tall cows. So they made the problem even worse than selecting for high milk yield.
Yes, that's very true. Sorry. That's very true, yes. It was not only selecting by, but also because of the shows that we have, the large and most angular cows got #1 in the shows. And the farmers with the more dual purpose cows were thinking, okay, I'm getting old-fashioned here. Let's use these bulls as well. If you put these cows on top on shows with more angularity, yeah, then you start brainwashing the farmers' population as well. When I started to do scoring contests, I was called judging contests in Wageningen at university. I graduated there as well. We did a lot of judging contests, and the first time I did it, the judge who was there to teach us, he said, because I made a total wrong ranking, of course, because of my own thinking, he said, Harman, listen carefully, a cow should be so sharp that you could cut a loaf of bread on her. Remember that when you score a cow, he said. So I never forgot that, but that's how we did it for a long time, and that's definitely influenced the perception on farmers for good cows.
Thank you very much.
Sorry, I can't resist this. Mike, could you stand next to Harman?
In terms of size?
And can we have this discussion about small and big animals? And do we prefer the Scottish or the Dutch.
Do take a seat and we'll refer back to you if we may. Let's widen it out. We only have 10 minutes or so before we have to chase away. I think I mentioned previously that Nick had given me some questions to ask. But before I get to them, is there any comment that people want to make, anything they want to add to the GenTore font of knowledge before we go down any particular avenue? It's your last opportunity as a group. Not your last opportunity. Yes, sir. You certainly get plenty of exercise, Nick, don't you? Yeah.
Thank you very much. The last presentation had all these key success areas which were highlighted. One of those that I think Nick Friggins did not mention, which I think is very important actually, and it came out in the first 3 presentations, is capacity building. I think this project has demonstrated that you can actually train people as they are doing research. Now, given what we've just heard from our panel farmer, of some capacity building that happens on the farm and also on the shows, how do we reconcile this, the formal learning in school, uni, and what goes on on the farm and also in the shows?
That's not just for our presenter. Anybody want to comment on that? We so far. Well, I could ask Claudia. She's closest, but I suppose.
Sorry, frivolous answer. I meant you should sack the lecturer who told Herman to select such angular cows.
But is that correct? I mean, maybe in the future we'll be rotating around again in terms of our knowledge. I don't know. So that's education. Any other comments? Nick?
Just to respond a little bit, this is something we struggle with, and so we've done a research project. We've tried to involve stakeholders, but we've really struggled to get down to the farmer level. We've had some stakeholder interviews, we've had panels with farmers, we've had vets and so on, but we do have this kind of layered system where the researchers talk to the advisors talk with the industry talk with the reps, and it's difficult to get all of those things into one place. It would be extremely useful to make that mix, but we tried and I would say failed. We've done what we could, but those are different projects. Perhaps the bovine has a different experience with their network.
That would be an interesting comment. Is Virginia prepared to say anything? You clearly have engaged, I'll come back to you, Jonathan, with farmers at a much more significant level than we managed.
Well, this specifically, this is about dairy. So our network is about beef, but I think that similar things can happen, and that's why I believe that we had to work together and listen ourselves to avoid the things to happen. And maybe this is something interesting also for countries that maybe are less developed or have worked less, not to repeat some mistakes. But I don't know.
Thank you, Mike. And I want to say thank you to Herman, first of all, as well, because I think it's so important at this stage of the project that actually we go back to actually a farmer, a breeder, and what this is all about. And I think Virginia's project shows that really well too. I think partial success, Nick, I would say, rather than failure, because I think it is really important for all of us with any research to take responsibility for sharing the results and making sure there's an impact. And I think the GenTore project has done that. I think we can do more. But what's interested me is actually every conversation that we have that involves farmers, and I'm a vet in practice, that changes what we do at a time of great need, a time of such disruption. I think we do have to do better, and every bit of research that we do, we have to make sure that people hear it. Otherwise, it is not as valuable as we think it is. I think one of the things I feel actually most proud of, though, is that throughout the project we have, in different stages, and every person that's listened is a convert and is a new thinker. And at the workshops we ran at the Precision Livestock Farming meeting in November in York, sat around the conference table, there were farmers, there were vets, there were agric students, there were breeders, there were government influencers, and the conversations that happened, they may have been small, but they were important. So I do think what we've done is valuable, but we can definitely do more.
Yep. And then what I'd like to do is to ask the three young presenters at the beginning for their view on how we might do better.
I just think that there's been so many important and good tools which have been developed here, so that we need to, and we have to go back, each of us in each country, and also try to tell all of the organizations, because what have been made here, because there's so much which, now I'm from Denmark, I know this can really be used, and we have some projects which could be, where it could be used into these projects. So I think we should try to encourage ourselves to at least go to the organizations and say, here's something that you should take up, and eventually, in many of our countries, have national meetings where we could say, could we wrap up on what has been done here, because there has been done so much important, Nick. I think that's really valuable for the industries around the European countries, so not to miss it. So I think we should do this within the next year.
Harriet, can I come to you first for a view? And I only pick on these people because they're available.
I'm just trying to think of something to add, really. I guess in future projects, and this is something that I think we did do within GenTore, is involving farmers at every stage of the process, not just at the dissemination at the end, but at the beginning when deciding what to do. And yeah, I think that makes the results that much more applicable. We're not researching something that isn't actually an important issue.
Can I ask, do you think we should have got them in at the design stage, which perhaps would be 18 months before the project launched or was even applied for?
Yeah. I mean, is that even realistic? I know we got them in quite early on, right? There were definitely interviews and things early on, but in designing the project, potentially.
Do people think we can get farmers involved in design, or is it always going to be driven by researchers?
I was just going to add a slightly different perspective on that idea of bringing farmers into project design, because that's exactly what medical research is doing. So I'm a consumer representative for a hospital in Australia, and I'm involved in the design of research projects. So if other areas of science can do it, why can't we? And in terms of a long-term view for fostering better connections between the wider farming community and researchers, one of the things that I've seen work quite well is pairing PhD students with mentors from the wider farming community, so that if they don't come from a farming background themselves, they have that opportunity during their studies to get that wider perspective. And that's something that you can start at the undergrad level and continue right through.
Thanks. I'm going to go to Alban first, Jonathan, as I come round, if that's okay, and see whether he's got a view.
So, from my perspective, what I've learned from GenTore, it is how powerful it is to combine different disciplines. So I am a geneticist, and I had to work with nutritionists, physiologists, and it's not always very easy, but I guess at the end of the day, I've learned a lot, and this makes also great contributions. So I don't know if it answers directly your question, but it was one of the good points, and I think it's one of the good points to keep for other future projects.
No, thank you very much. That's a really interesting point. Jonathan, and then Emma, if you want to add, you will.
Thanks, Mike. Working with nutritionists is particularly difficult, isn't it? I think we should make that. We should make that point. or one nutritionist is difficult anyway. I think the interdisciplinary thing is really great, isn't it? It is important. But I want to pick up the point about farmer involvement, because there's some formats of research. So at the moment, we're involved in some research starter work where it has to involve a farmer leading the research, and they have to have at least 50% of the grant going directly to them. And it's a phase which designs larger research programs, but it means the farmers actually, and the initial application is in video format, with farmers recording just basically video around half a dozen questions, but they have to do the videos and they have to be involved. And it's just a very disruptive way of thinking about starting projects that can then lead to bigger programs, but they're farmer started and they get paid. So.
Right. I don't know whether you've got a comment, Emre.
Well, I don't know what to say, but I think GenTore was a good bridge between the science and industry. At least that's how I feel from the Danish side, because some of the tools and knowledge that we gained from GenTore project, we already have them in pipelines to implement in Denmark. So it's been very useful, and of course it opened up new questions, like Mike mentioned in the earlier sessions, that there are still things that we can improve in these models and methods, but I don't think you are considering another GenTore project. Thank you.
Thank you very much. So do we need a project on identifying farmer stakeholders?
I just wanted to ask you a question about your consumer committees. Is that something that is sort of set up as a standing initiative which sits there with the hospital, and then when projects come along, you feed in, or was it set up specifically in relation to particular projects?
The hospital that I'm involved in has a dedicated staff that work to involve consumers or patients throughout all aspects of hospital life. So there's a regular newsletter that comes out with different research projects or consulting, patient feedback opportunities. So there's a variety of, techniques that the hospital uses to get patient feedback. One of the projects that I was part of, the early scoping interviews, the total direction that the lead investigator thought they were going to take with the project went 180 degrees after she did the initial scoping interviews with the project. Yeah, so.
Okay. What about the gaps? Have people identified knowledge that we ought to seek and don't have? Do people have opinions on that, or is it just a continuation of the work that you've been doing? Eileen's put her hand up, and I particularly wanted to comment that you broadened it right at the beginning of your presentation, which a lot of people picked up, and I think that was quite useful. And you could throw small remnants into what you've found out, because that's where a lot of meat production is in the world.
Not those woolly yolks. Sheep meat is the only red meat that is going to increase around the globe, and goat too. I was wondering, not because Joe just said it, but what about final consumers of the products, or the ones that are choosing not to consume the products? But I probably think, as Mizek far more eloquently said, crossover about how these tools translate practically, because they mightn't work, because completely different systems, more diverse genetics, etc., etc., etc. I think really the extension into outside of European developed, in the worst sense of the word, agriculture is probably more important. But I do think we need to listen to consumers, because they're going to drive what the FAO tells us in 10 years' time.
Yes, famously the Meat Institute in Bristol used to have taste panels, so they did actually have that sort of structure. Just interesting from the production, from the structures that we've been shown, even for new projects, that dissemination comes at the bottom. Is that the right focus? Maybe we should be turning it on its head in that respect. Anybody else? Yes?
I would have thought that in terms of threats to the ruminant production industries, methane production is just vastly more important than everything else. The societies and governments will close us down completely by 2050 if they really want to achieve net zero. And there was a little bit about methane, but if you look at the importance of it, it should have dominated the meeting instead of being a very small part.
I should ask Herman, do you get paid for selection against methane for your cattle?
Certainly not. No, certainly not. Well, don't get me started on the CO2 and methane discussions in ruminants. But no, I was thinking about the gaps you were mentioning one question before. Are we missing a gap in our knowledge or in our implementation of it? I think one important thing we're missing is the implementability of the knowledge we're gaining here, because there is a very important step between you and the breeders or the farmers, and that is AI organization or AI stations calling themselves breeding organizations today and interfering with our decision. They decide which bulls we use. Not me, because we're stubborn enough to use our own bulls, but most farmers pick the bulls from the ranking from their AI stations. And we don't have a lot of influence on them because they are the commercial lead. In Holland, I can speak for Holland, the largest and most commercial AI semen selling organization, Holland Genetics, took over the national herd book, you won't believe it, but they did 25 years ago, and changed it into CR Delta. So from that time on, a commercial organization was able to make all the rankings, all the breeding value estimations from all the bulls, not only from their own, but from all their competitors as well. That has been the wrong structure and still blocking a lot of improvement coming from science to the breeders. I think that's a gap or an obstacle we have. Well, I try to put it in these little pictures that how can we get good knowledge about efficiency and resilience into the rankings of the bulls that are actually being used, because today we're using bulls like the ones I showed you on the picture, resilient or not.
Thank you. Oh, sorry. Was there a question here? Yes.
I had two questions for you. So how do you compare in your scheme here, how do you compare the animals between farms, and so in order to get, from my point of view, a fair use of the bulls, of the AI bulls of the different farmers? And the second question, so what is the size of your farm and how do you manage the genetic diversity?
We have a size of about 50 dairy cows, always had, and that's more than enough to maintain the diversity, because we have bred with it for 50 years and only bred with our own bulls. We have been genetically closed farm, so to speak. We only use 5 bulls every year, at least 5, from our best cows, and they served the herd the next year. Not the closest matings, but of course everything is family. It's a line-bred population in our barn. Everything's line-bred, of course. But that's no problem for 50 years. We never get calves with 2 tails or 2 heads, or not, at least not more than in the Holstein population. Luckily, we never had. But talking about inbreeding, we can also, don't get me started about the Holstein breed today. Talking about inbreeding. And the other one here is then, the idea is, like the pig breeding, in the pig breeding it's already been established this way. You have the top breeders breeding top lines, A lines, B lines, C lines, only using their own boars. So these farmers, these breeders should use their own bulls and establish a line within the breed. and then that semen should be distributed. And these farmers decide, these breeders decide, which are their best bulls. I know which bulls are my best bulls and which cows are my best cows. I don't need a model to tell me which cow in my barn is the highest or the best. I know which ones are. So let the breeders decide which bulls go to the AI, and then let users or farmers that don't love breeding as much as we do and just want to have a group of resilient and efficient cows, they can use different bulls from A, B, C, D lines and continue breeding within a breed without inbreeding and having resilient and efficient cows. That's the idea.
Thank you. Well, time moves on, so I think we should conclude and we should give the microphone back to Nick. But before we do that, I don't know whether anybody was going to thank him for leading us for the past 5 years. I'm probably one of the older members in the audience, so as a senior, purely by age, on your behalf, I'd like very much to say thank you. It's been an interesting task, a challenging task in challenging times, and yet we have got to the end with, I think, a lot of useful information that clearly we think we need to transmit better to others, particularly farmers and end users. But having said that, I think he's led us with great good humour, fair balance throughout. We're a diverse and argumentative lot. We don't always agree, but as a good leader should do, he's got us there as a coordinated group and as a team. So if we were in the Dutch First Division, we would be up there with Feyenoord, maybe not at the top, but certainly not at the bottom like Sparta. Okay, I hand you over, and a round of applause I think is well due.
Thank you, Mike. Thank you very much, Mike. So we're near the end. Thank you, Harman, for your views. I'm sure there are people who don't agree with everything, but what I take away is that you're very interested in having resilient and efficient cows. I think we actually agree on what some of the things to do with resilience are. The body, the reserves and everything. Then we can discuss over a beer how we actually get there. Okay. So, there's a talk called GenTore End. Here we go. Yep. So, this is the formal last meeting within the project of GenTore. As Jonathan has said, as other people have said, I do hope that we go on presenting. It'll happen all this week. It'll happen at EAP, and I hope it happens all over the place. And as Morten said, that we really take this out there as best we can. It's been a pleasure to lead GenTore since 2017. We started off in a heat wave in France. It was 35 degrees. There were people sweating from places they didn't know they could sweat from. We nearly finished in a heat wave, because if we'd done this a week ago, we would have been in the same position. So climate change is with us. I picked up a few pictures of the group. This was in the newsletter, the first newsletter. GenTore shines in Edinburgh. We also had a cracking good week in Edinburgh. And generally, we had a sunny disposition for the project, I would say. It didn't always work out like that. We did have some rain. But we did also always look upwards for inspiration and head for new goals. And that was really great. GenTore has been creative in lots of different ways. Lots of wacky ideas, lots of vulgarizing of the logo. And so really what I want to say is it's been a pleasure, and a huge thank you to all of the GenTore family. I would especially like to thank Agathe, who couldn't be with us today but put a lot of effort in to make it all run very smoothly, the work package leaders, but everybody. It's been a great time, and I think we've had fun, and those of you who know me, I think if we have fun, then we do good things. So thank you very much, everybody. Don't forget GenTore at WC Galp, and please, please don't forget the website. There's all kinds of groovy things on there. There are scientific papers, there are videos, there are infographics. There's all that you could possibly want, and that site will stay live for a good 5 years. It won't stay live, it will stay there. It'll be there, and we will add the new papers that come, but that resource will stay there. And what we presented today will be available in document form, so those who are interested can go and dig deeper in that. That was it. Thank you, everybody. I can see... one of our commercial partners has very kindly produced us some T-shirts. So those of you who are in the GenTore project can come and collect a GenTore T-shirt and can wear it with pride all week, even when it starts smelling. Thank you, everybody.
If you are not a partner of GenTore and would still like to come to the reception this evening and you had asked for it during registration, please come to me.